2. Okay. And so 8 is 2 times 4, right?
Yeah. 2 times 2.
Now look here. 2 times 2 is
4.
So isn't this 4 times 4 times 4? So what's the cube root of 64?
4.
4, because it takes 3 4s to make 64. So roots break things down. Whereas if I raise something to a power, it builds it up. Right? 3 squared is 9. The square root undoes that. 4 cubed is 64. The cube root undoes that. Brings it back down to just 4. Let me stop there for a second. How are you guys doing so far? If you understand square roots, all the other roots use the same idea. They just have to have more of the thing. So this says, what does it take 2 of? This says, what does it take 3 of? A fourth root would be, what does it take 4 of? Of course, the higher the root, the harder the problem. That's true. You might be able to guess that. So we're not going to go crazy and do like an 11th root or something. Don't worry. Now, let me see. There's a beautiful... I understand students are always like, don't use that word beautiful with math. There's a beautiful analogy between, like, what is 12 divided by 3?
4.
Now, let's talk about this a different way than I did earlier when I was talking about the zero weirdness. This means that there are 4 3s that are in 12, right? So what happens if I try to do 13 divided by 3? Now, let me show you a different way to make it a mixed number than you might have ever seen. I can't remember if I did this with you guys yesterday.
No.
Okay. Some of you guys remember, you just kind of do the division, right? So 3 times 4 is 12, and then you subtract, so it's 4 and
1/3.
Do you guys remember that? So here's another reason that's true. I'd love for you guys to see this, but it's not necessarily easier to do it this way. It's just another way to see it. 13 is 12 plus 1, right? And I picked 12 because 3 goes into 12. It's the next number down that 3 actually goes into. How are we doing so far? And isn't this, so what's being divided by 3? 12 is being divided by 3, and 1 is being divided by 3. And of course, 12 divided by 3 is 4, and 1/3.
What now?
All right, let me let you absorb that. I didn't just show you a different way that I request you to do this. No, you never have to do this ever in your whole life if you never want to. But the more you see this kind of thing, the more connections you make about how numbers work, right? So let's try one more of these before I come back to radicals. I'm just going to erase this away. So what if I had... What you got, Jeff? I don't know, man. 52 over 7. 52 is a bad number for 7. What's the next number down from 52, like I did with this 12, that 7 would like?
49.
49. Is that cool? Mm-hmm. So I can break this up as 49 plus 3. So it's 49 over 7 plus 3 over 7. And do you guys see how 49 sevenths plus 3 sevenths is freaking 52 sevenths? I'm not doing anything amazing. I'm just breaking the number up. But now I've broken it up into a part that I can do and a part that I can't do. So the part that I can do, I do. And the part that I can't do, I just freaking leave it. Poor little dude, right? So it's had an extra 3. If only I didn't have that extra 3, it would have went in beautifully. But I have that freaking extra 3. Oh, shit. Right. And again, you never have to do that in your whole life after this if you never want to. You never have to. But it's just good to see that at least once.
So you picked 7 because...
I didn't pick 7, I'm sorry.
You picked 49, I'm sorry.
Yeah.
Because that was the lesser number that went into 7.
Beautiful. Right, if only this would have been 49. The next number down that 7 likes. And then I can just write next to it what the excess is. So that's what that remainder really means is how much bigger this number is to have made it become something that it would go into evenly. That's what the remainder always means, is how much excess you got. I love it. And this is all kinds of, when you first learn this stuff, they should have been telling you this. So, I know. I don't know what Common Core does. It'd be awesome if it did some of this, but I won't hold my breath. So how does this apply to the square root stuff? What's the square root of 25? This is getting 5. I love it, right? So that's not what this applies to. What about the square root of 50? Can I do the square root of 50? What times itself is 50? 25 times 25 is big.
No.
See what I'm saying? So it's not adding to itself. It's what times itself is 50. So of course, please understand, I picked 9 earlier because 9 works. If I would have said the square root of 10, there's a whole bunch of numbers that I can't do the square root of and get a nice answer. Right? I can use 9, I can use 16, but every number between 9 and 16 have ugly ass square roots. Poor little numbers, right? Square root of 11, oh my God. You could guess what it is, though. Square root of 11 would be between what and what? What's the square root of 9?
3.
What's the square root of 16?
4.
So the square root of 11 is between... There you go. So you can get an estimate for it, but you don't know what the hell it really is. Do you see what I'm saying? Square root of 50 is the same way. What is that close to? That would have been a much nicer number to put in here.
49.
All right, I like it. I'm just saying that just to say, if I would have put 49, it would have been great. Now, what operation are square roots kind of based on? They're looking at what it takes to multiply, right? So what part of 50, when I factor it, when I write it as something times something, can I do the square root of? Sort of like figuring out this number, right? Why did I put it 49? Because I knew I had to divide it by 7, and that's the next number down that actually would work.
5 and 2.
Yes. This is the part that is definitely going to be brand new to almost all of you. This is neat, though. This is the next, just one little step away from being able to do square root of 25 is being able to do something that has a 25 in it. You should be able to do something with that.
Break it down to 25 to 5.
You ready? Right? This is the part you got to really understand. This is sort of like this part here.
Okay.
I can break this up as the square root of 25 times the square root of 2. As long as they have the same root, you can multiply them together or pull them apart. I mean, is everybody decent with that step? So you see how it's sort of like this step to this step, breaking it up? So now I can do the part I can do, and I can leave the part that I can't do. So what's the square root of 25?
5.
5. What's the square root of 2? I don't freaking know. Right. Over here, same thing. What's 49 divided by 7? 7. What's 3 divided by... I don't freaking know. I'm just going to write it. Let somebody else worry about it. Do you guys...
So you leave whatever's left under the square root sign, and the thing you can do, put on the outside.
Exactly. I like it. It's the same exact thing. I really hope some of you guys see what I'm saying. It's not the same exactly, of course, but it's the same idea. Do the part you can do. Leave the part you can't do.
So could you write that like that?
How do you mean? Well, there's no radicals over there. So, you know what I mean? So it's the same idea, but on different operations. Okay. So you can't write them the same way, but it's the same idea. Break the thing I'm asked to do something with down into parts that I can do something with. Break this thing into parts that I can do something with and I can't do it with. Let's do another one. By the way, today obviously is going to be a lot of me talking. Tomorrow I'm going to have a little handout for you guys to work on, and I'm hoping that you guys can get into chapter 1, review homework, and come with questions, right? So tomorrow will be a little more question and answer and group work stuff. Today I just got to get it all out there. So another example. So that's example 1. Here's example 2. What you got, Jeff? Let's do square root of 20. I like it. So you are thinking about breaking this up into factors where one of the factors is a nice number for a square root. So tell me some numbers you could take the square root of. 4, 9, 16, right? So obviously we already hit one that goes into 20. Does 16 go into 20? No. Go into it, like divide it. So how can I break this up?
Square root of 4 times
Yeah,
square root of
it'd be
2.
4 times
2.
5.
5, sorry.
Let me stop there for a second. Why did I pick that and not 10 times 2? Because neither 10 or 2 are square rootable, right? Okay, some of you guys are getting me. Some of you guys are like, what am I doing? Again, this is the first time that most of you guys have ever seen this, am I right? Yes. So you got to let it kind of sink in. You got to mold it around your brain. So I really wanted to make sense. Why did I not pick 10 times 2? Because that's what 20 is. Because what's the square root of 10? I don't freaking know. What's the square root of 2? Oh, so you're just as good as you were. But here, What's the square root of 4?
2.
Holy shit! Okay, that's infinitely better than where I was because I can actually do something. So this is the square root of 4 times the square root of 5. That's what the square root of 20 is. Square root of 4 is 2. Square root of 5 is, I don't freaking know. And it's exactly the same as writing 7 and 3 7. 7 I know. 3 divided by 7, I don't know. I'm just going to write that. Shit. It's exactly the same idea. So let me give you one to try on your own. I'll finally shut up for a minute. You guys try this one. Don't say anything out loud. Just... This is not too evil. So I picked a number that's kind of the first way you would think to break it up is pretty much the way you want to do it. But just to kind of start off wrong, 45 is 3 times 15. But that ain't doing me any good because I can't do the square root of 3 or the square root of 15. So I don't do it that way. Of course, what's 45 a better way to do it? Yeah. Square root of 9 times square root of 5. 9 times 5 is 45. And what is the square root of 9? 3. And what is the square root of 5? I still don't think it. I like it. I'm going to try to shove one more idea in the brain, and then we're going to go off on our field trip. Head out a little bit early. If that's all right. Because we're doing quite a bit, and I want you to have time to catch up with your homework to come with questions tomorrow. Here's one more. Here's the one more idea. Let me start off with an easy question, and then I'll bring in the radicals. What is 3y plus 2y?
5y.
5y. Alright, that's amazing, right? Okay. This is like terms. Are you with me? So for example, what is 3y plus 2x?
3y plus 2x.
3y plus 2x. I can't do anything with it. Because they're not like terms. So then thinking that way, what do you think 2 square root of 3 plus 4 square root of 3? What square root of 3? Do you know? No. So what's 2 things plus 4 things?
6 things.
6 things. 6 things. You see how that acts just like a variable? Because what's a variable? It's a number I don't know yet. What's the square root of 3? It's a number I don't know yet. So I'm just collecting how many of those things I've got. I got 2 of them over there, 4 of them over there, I got 6 of them in a pile. I like put them out by the curb, let them pick it up.
Nothing happens with the continuum. It's just a variable.
Here?
The radical. Basically.
Oh, the radical. See how, look at this answer right there. Isn't it y? Did anything happen with a y? In a sense, no. But because I was collecting how many y's I got. I got 3 of these plus 2 of these is 5 of these. I got 2 of these plus 4 of these is 6 of these. Is that cool? So on one level, you probably don't believe me almost because you're like, radicals are always hard. This looks easy. Stop it. Stop it, Jeff. You're not selling this right. But the idea of like terms applies when this thing is something I don't know and I just collect how many of those things I got. I don't know, but I got 5 of those weird things sitting there staring at me, right? So let me see. So what if I had this? Square root of 45 plus 7 square root of 5. Are those like terms?
No, wait, yeah.
I got 7 of these and 1 of those, right?
So it would be
If this is the square root of 5, I could do it, couldn't I? I got 1 square root of 5 plus 7 square root of 5 is 8 square root of 5s.
Well, couldn't you like break it down?
Ooh, there you go.
Yeah.
That's why I was trying to do the same problem we just did. Because what happens, I really want you guys to understand that this is like X and this is like Y.
So 9.
Right? They're different unknown things. I can't put them together. I can't consolidate them.
3 and 5.
But the square root of 45, you can break it down as
3 squared to 5.
Square root of 9 squared to 5. 3
So
squared to
10
5.
radical 5.
Plus 7 squared to 5 is
10.
10 freaking square root of 5. I love it. So knowing how to, this is what I call reducing the radical. It's called simplification, but I call it reducing it. This is like lowest terms for that radical in a way. It's not the best technical language to use, but it feels like that work. You can't stop here because you can do something to it. Same with a fraction. You can't stop at 6/8 because you could do something with it. And when you get them all the way down reduced, maybe you have more like terms than you thought.
Why are we calling this simplification versus solving it?
Solving implies you have an
Answer.
Equal
Sign.
sign.
equation, an equal sign. Right? Solving specifically means you're figuring out what values make the statement true. And you can't have a truth question unless you have an equation, like an equals. A claim that this equals that. Well, when does that equal that? This is just numbers in space that I'm trying to add together.
Okay.
So simplify means do the operations. That's what simplify means. Solve means figure out the values of the variables. Yes. I like it. Okay. All right, that's all I want to try to cram in your brains today. So let's do this. You guys, we're going to head out towards the Tech Mall. So just kind of start going in that direction. I'm going to run out in front of you guys and catch up. Okay?